Hello children, welcome back to chemistry session. In previous session, we have seen reaction of metal carbonates and metal bicarbonates with acids. In that activities, we have observed that when metal carbonates and metal bicarbonates reacts with acids and they evolve carbon dioxide gas. In today's session, we are going to talk about reaction of non-metallic oxides with bases and reaction of metal oxides with acids. Let us start today's session, children. Reaction of metallic oxides. Metallic oxides with acids. Let's see reaction between metallic oxide and acid. Let us consider the metal oxide such as sodium oxide. Sodium oxide and consider an acid, hydrochloric acid. Here let us consider aqueous solutions of sodium oxide. It's a salt, aqueous sodium oxide and aqueous hydrochloric acid. Remember, these two are colorless salts, colorless compounds. When we mix together, which form new compound, that is sodium chloride plus water. Let us verify the equation, children. Na2O plus 2HCl. Use ratio to NaCl plus H2O. Let us verify the equation. 2 sodium atoms and LHS. Here 2 sodium atoms. Here 2 chlorine atoms. Here 2 chlorine atoms. Hydrogens here 2 H2. 2H here H2. Here 1 oxygen atom. So 1 oxygen atom. It's a balanced equation. Here colorless aqueous solutions of sodium oxide and hydrochloric acid. When we mix together, which forms common salt, that is sodium chloride is a salt and forms water. Let us consider one more example, that is colored salt. Colored salt is CuO. CuO means cupric oxide. It is a blue color salt. Here cupric oxide is a blue color salt. Now when we add few drops of few ml of hydrochloric acid, aqueous hydrochloric acid to the cupric oxide salt, then there is a change in the color of the salt. The salt will become colorless, CuCl2 and forms water. Let us verify the equation. CuO plus HCl is CuCl2. Here 2 chlorine atoms are here. So write here 2 HCl. So CuCl2 plus H2, 2HO. CuCl2 plus H2O. Here CuCl2 is a salt. Here NaCl also is a salt. Observe the two equations. In equation 1, sodium reaction between aqueous solutions of sodium oxide and hydrochloric acid forms salt, that is sodium chloride and water. In second equation, reaction between copper oxide or cupric oxide salt, solid, and hydrochloric acid, aqueous hydrochloric acid, then which forms CuCl2, cupric chloride salt, and forms water. So when you notice the equation, you can observe that here hydrochloric acid is a base. Hydrochloric acid is an acid, children, and which forms salt and water. So then what would be the nature of metal oxide here? Here metal oxide would be basic nature, children. Because in previous session we have also discussed neutralization reaction or acid-base reaction. Neutralization reaction or acid-base reaction means when the reaction between acid and base to form salt and water. Here products are salt and water, and here one of the component is acid. That's why the metal oxide should be basic nature, and the reaction between base and acid to form salt and water. So in general, we can conclude that most of the metal oxides are basic nature, children. That's why metal oxides like potassium oxide, calcium oxide, magnesium oxide, zinc oxide, etc. These oxides, these are some of the examples of metal oxides. These metal oxides are basic nature. Metal oxides are basic nature. That's why these metal oxides react with an acid. Metal oxides react with an acid to form salt and water. So the general equation of above experiment is metal oxide reacts with an acid to form salt and water. This is the general equation of reaction between metal oxide and acid, because metal oxides are basic nature, and reaction between base and acid to form salt and water. This is the reaction of metal oxides with acids. The interpretation of this experiment is metal oxides are basic in nature. Next, let us talk about reaction between non-metal oxide and base. Reaction between non-metal oxide. Reaction of non-metal oxide. Non-metal oxides with base. Let us consider non-metal oxide such as sulfur dioxide. Sulfur dioxide is a non-metal oxide, children. When sulfur dioxide reacts with base such as sodium hydroxide. When sulfur dioxide reacts with sodium hydroxide, what do we get, children? Here when sulfur dioxide, it is in a gaseous form. When sulfur dioxide gaseous passes through the aqueous sodium hydroxide, which forms sodium sulfide. Formula of sodium sulfide is Na2SO3, children. Na2SO3 is sodium sulfide and forms water. Sodium sulfide. Let us balance the equation, children. Here 2 sodium atoms. Here write 2 Na2, 1 sulfur atom, and 3 oxygen atoms here. Here 2 oxygen atoms, here 2 oxygen atoms, 4 oxygen atoms are here. Here 3 plus 1, 4 oxygen atoms, and hydrogen atoms 2. Yes, 2 sodium atoms, 1 sulfur atom, and 3 plus 1, 4 oxygen atoms. Here 2 oxygen atoms, here 2 oxygen atoms, 4 oxygen atoms, and 2 hydrogen atoms. There 2 hydrogen atoms, here 2 hydrogen atoms. This is a balanced equation. Here sulfur dioxide reacts with an example of non-metal oxide. When sulfur dioxide reacts with aqueous sodium hydroxide, which forms sodium sulfide, and here Na2SO3 sodium sulfide is a salt and forms water. Take one more example. Carbon dioxide. Reaction between carbon dioxide and base, such as lime water or calcium hydroxide. When carbon dioxide gas passes over the lime water or calcium hydroxide, which forms calcium carbonate. We know that, children. Calcium carbonate is a salt or precipitate plus water. Let us verify the equation. Cl, O2, here 2, 4, CO3, here 3, plus 1, 4, here H2, so it's a balanced equation. When carbon dioxide gas reacts with calcium hydroxide, it's a base to form calcium carbonate and water. Here, sodium hydroxide and calcium hydroxide are base. You know that? And sodium sulfate and calcium carbonate is a salt. And plus water. Here products are salt and water. Here it is a base. Then non-metal oxide should be acid. So when acid reacts with base, it forms salt and water. This is nothing but neutralization reaction or acid-base reaction. So based on this activity, we interpret that non-metal oxides are acidic in nature. When acids react with base to form salt and water. That's why the general equation is non-metal oxide plus base gives rise to salt and water. This is the general equation of non-metal oxide and base. That's why non-metal oxides are acidic in nature. So when acid reacts with base to form salt and water. Earlier we have discussed the metal oxide. Metal oxide have basic nature. That's why metal oxide reacts with acids to form salt and water. Here non-metal oxides are acidic nature. Whenever they react with base to form salt and water. So we have seen that metallic oxides are basic in nature and non-metallic oxides are acidic in nature. How can we say that metallic oxides are basic in nature and non-metallic oxides are acidic in nature? Let us see that. Metallic oxides like calcium oxide. When calcium oxide is dissolved in water, which forms calcium hydroxide. Here calcium oxide is a metallic oxide. It's a metallic oxide. When calcium oxide dissolves in water, which forms calcium hydroxide. Aqueous calcium hydroxide. Which calcium hydroxide is a basic in nature. It's a base. Let's take one more example. Magnesium oxide. Magnesium oxide is a basic oxide. It's a metallic oxide. Next, when magnesium oxide is dissolved in water, which forms magnesium hydroxide and the OH twice. Here magnesium oxide is a metallic oxide. When magnesium oxide dissolved in water, which forms magnesium hydroxide. Magnesium hydroxide is a weak base. So based on this, we can say that metallic oxides are basic in nature because aqueous solutions of metallic oxides are basic in nature. So they are also called as alkalis. Alkalis means soluble base. Next, let's see. Non-metallic oxides are acidic in nature. Non-metallic oxides like carbon dioxide. When carbon dioxide gas is dissolved in water, or when carbon dioxide gas is sent to the water, what do we get? We get carbonic acid, H2CO3. Aqueous carbon dioxide is called carbonic acid. It is an acid. Carbonic acid, it's an acid. Here, carbon dioxide is a non-metal oxide because carbon is a non-metal. The non-metal oxide dissolved in water is produced acid. Let's take one more example. SO3. SO3 is sulfur trioxide. SO3 is sulfur trioxide. When sulfur trioxide gas is sent to liquid water, which forms sulfuric acid, H2SO4. H2SO4. Here H2SO4 is sulfuric acid. It's an acid. And sulfur trioxide is a non-metal oxide. So when sulfur trioxide dissolves in water, which forms sulfuric acid. So based on this, we can say that metal oxides have basic in nature, non-metal oxides are acidic in nature because equation 1 and equation 2 are examples of metallic oxides and water. And equation 3 and equation 4 are example of reaction of non-metallic oxide and water which produce acid. Based on this, we can say that metallic oxides are basic nature, non-metallic oxides are acidic nature, because those oxides produce bases as well as acids in their aqueous solution. In aqueous solution, basic oxide produce base. In aqueous solution, non-metal oxides produce acids. That's why metal oxides are basic nature, non-metal oxides are acidic in nature. This is today's session. Today's session is reaction of metal oxides with base, reaction of metal oxides with acids, and reaction of non-metal oxide with base. I hope you understand today's session. We'll meet in next session. Thank you, children.